class, how are you today? Are you okay? I really hope so. Today we are going to talk about the asymmetric encryption. In this case we are going to explore to break the private key, and we are not going to use the brute force. We are going to use the division attack, okay? Exploring the integer factorization to find the private key, the D value. So we are exploring the asymmetric encryption, the RSA, and we are going to encrypt this image, and with our division attack we are going to find out the private key, the D value, exploring the integer factorization and decrypt the image. Okay, it's a way to attack the key without the brute force. Otherwise it would take much time to take the correct value. So we are going to use math here. I'm going to close this image. Now we have the algorithm to create the public key in the RSA, the asymmetric mode. I have commented the private key because we don't want to create it, we need to break it with the division attack. First we need to create the PN key, so it's gotta be the prime number. So I'm creating one with just 32 bits, okay, for each one. So this encryption, we can say it's the 64 bits of the complexity. And I'm created the function. The n, it's the product of the PN key, it's the RSA modulus. The phi, it's the Euler tangent function. It's the p, it's the prime, it's the first number per minus 1 multiplying the q minus 1. Okay, this value, it's common usually to create the number e. It's like the public key. Okay, it's a prime number either, but not necessary it should be. This number gives a good performance and security. Here it's the line to create the private key. Okay, that it's what we are going to explore and break. It represents the D, it's the modular inverse of the modulo phi in n. Okay, like it's making the account like that, like the e multiplying some value, let's call it d. Okay, and getting the rest of the module of the phi, and it's gonna give us the number 1. That's because we have the minus 1 here. Since I have commented the private key, we wouldn't need to create the private key. Okay, and neither do this account, neither the phi. That will be enough to create the public key. Okay, I'm returning the two functions, two values to the function, the public key and the private key. The public key is the number 0 and the 1, it's in this case it's the E, and the N, it's the number, it's the pub 1, okay, which represent the P multiplying the Q. So let's create it. There is our public key. There it's what we share with another users to encrypt the files, and you receive the file encrypted, and with your private key you decrypt it and you are able to read and so on. So in that case, I'm the attacker. I want to create your private key with the division attack, okay, and we need to understand which values is it's the P and the Q, okay, so we can create the private key with those two values. Since I have the public key with the number E and the N, we are going now to explore the factorization, the integer factorization. Let's search the import math. The number N we have here. Now we need to make the factorization of the values to find out the P and the Q. Since we know those numbers is prime, we need to search the rest, like for I in range. Let's start it with 2 and end up with we can use the integer value of the N to the power of the 0.5 plus 1. What is that? It's I'm creating the square root of this value, because if we have the square root of this value, I can say all this number, we have those two values inside the P and the Q inside of the square root of this N value, okay. And now if N, the rest divided with I, it's equals 0, we have the first value. We can call it the P, it's equal I, and the second one, it's the division of them. Like example, if we have this number, it's equal P and Q, and if we have this value, example like that, now we can see the P. In this case we have the P, its value. Now we can find out the Q, and we can do that with the Q, it's equal 1 divided with the I. So with those two bars we get the values, okay, not the rest and not the result. And we can say the print factories of the P and Q. There is it. There is our awesome division attack. We can create it first print to know how many attack we are going to use with the factorization, like the print tries, and call that, so we can see the square root of this number and see how many tries we are going to explore here. And we can break this function, because if when we find out the P and the Q, there is nothing more to do. There is pretty important to use P and the Q different values, okay? Because if we created the square root of the n and the P and the Q, it's the same values, it doesn't matter how big it's the number, because since we have the square root of the number, we are going to receive the P and Q, and the code is break and completely lost. In that case, the P and the Q must be different values. We no need the math. Let's import the time to take a look how many seconds it's to find out the P and the Q values with the 64 bits of the complexity of the P and the Q, 32 for each one. Import time, and we start it with start time. It's time. It's giving us the first value of the time, and here we created the final time. It's the time plus time, and the result it's the final time minutes the start time. Okay, print the result it's giving us in second. Okay, so let's run it. What the fuck, man? I can't make one video without those fucking errors and bugs. Fuck. Why I'm using that? Not running. I'm giving the break, but we gonna see how many seconds it's to find the P and the Q. Okay, so there is the seconds values. Let's make division. Almost 10 minutes to break 64 bits of complexity of the P and Q with my computer. Okay, you can use the supercomputer and quantum computer, and you can break key much more bigger. Okay, but even so, if we pass the value of the P and Q of the 2048, we wouldn't be able to decrypting it because the key is very large. Okay, not with those supercomputers I have said about, and further on, the most encryption it's hybrid way, so they use the synchronous, I mean the symmetric ways to encrypt the file, and the asymmetric ways to encrypt the key, the public key file, the symmetric key file. Now let's check if it's correctly these values. Okay, don't know yet. We need to create another one for the private key. We're gonna pass those values. We don't want to more the public key. just the private key, and the values it's here. Let's see if it's the correctly one. Let's create it, and there is here the private key. This is the D value. Okay, now if everything is correctly, we are going to encrypt the image and decrypt that encryptor. We have a simple file to encrypt the image and decipher the data inside the image in the bytes mode, in the binary mode. So let's run the encryptor, the file Baba Yaga PNG, and there is it encrypted. We no longer can access the image. Now let's use the decryptor with the private key here. We are calling the private key we have created with the attack with the math, okay, making the factorization of the P and Q values. And now with the decryptor, let's run it and call the Baba Yaga PNG. It's running, and there is it. Let's see if we have decrypted that with our attack, with our crack the private key. And there is it. There is the image cracked with the flag pawned as H. So there is it, fellas. I truly hope you have enjoyed this cracking private key with the factorization of the n values. Okay, that's all for now.